Here is a question that I'd like you to keep in mind as you go through the contents of this video. Why is it that TensorFlow is so popular for neural networks? What is it about TensorFlow structure that lends itself so naturally to the construction of complex neural networks? Let's now turn our attention to TensorFlow, which is a specific library, a specific technology, which is incredibly popular and powerful for machine learning these days. Let's be really clear about what TensorFlow is. It is an open source software library for numerical computation using data flow graphs. This is something that we get from the TensorFlow website. Different bits in this definition are worth paying attention to. The first is that it is open source so that anyone can use it. This was very graciously open sourced by Google. The second is that this is actually a generic numerical computation library. So there's nothing which says that you can only use it for machine learning or neural network applications. And the third is that it models these computations as data flow graphs. This idea should not come as a very new one. If you've used other bits of software like Apache Flink or Dataflow on the Google Cloud platform, you'd see that the idea of representing operations on data in the form of a directed acyclic graph is actually a pretty old and well established one. We'll get back to the computation graph in a fair bit of detail. Let's keep moving. Let's now consider some of the formidable advantages of TensorFlow. These are all reasons why TensorFlow has become so popular. For one, it's distributed, and as we've already seen, the ability to run a complex computation on a cluster of machines on multiple CPUs or GPUs is increasingly important as datasets get too big to fit in memory on a single machine. A second important advantage of TensorFlow is that it lies at the heart of an entire suite of software tools. In addition to a bunch of powerful libraries available within TensorFlow, there is also TensorBoard, which is a visualization tool which you can access via the browser. Another associated technology is TensorFlow serving. This is a way of deploying trained machine learning models into production. It's quite sophisticated. For instance, there are ways for clients to automatically pick up updates in the trained TensorFlow models. These are formidable advantages. Let's also try and place TensorFlow in the context of other tools in machine learning. Let's try and understand its uses, its advantages or strengths relative to some other technologies, and also some of the challenges that you ought to expect if you decide to work with it. Let's start with the common uses. By far, the most important use of TensorFlow is in the research and development of new machine learning algorithms and applications. Implementing a neural network, architecting it, making all of the design choices, this is a fair bit of configuration work, and TensorFlow really does its best to abstract the hard parts away from you. So, again, the number one use case for TensorFlow is in researching and developing new neural network based applications. TensorFlow also has proper support for taking models from training to production. There is distributed training, and there is also TensorFlow serving, which helps with sophisticated deployment mechanisms that we just discussed very briefly. TensorFlow works really well for large scale distributed models and in applications like mobile and embedded systems as well. If you're surprised that TensorFlow is able to play at both ends of the field, as it were, at both ends of the spectrum of complexity, it's because Google constantly releases different versions of TensorFlow. For instance, there are lightweight versions available for use for mobile apps. It's possible to pre-train a model on a very large amount of data and then make that model available for use where other users can just tweak maybe one layer in the neural network and use it to their own ends, even on a lightweight device. Let's also quickly iterate through some of TensorFlow's strengths. Maybe the most important of these is the ease of use through its Python API. It has a easy and stable Python API. It runs well on both large and small systems. As we just discussed, it's actually possible to train a model on a large set of hardware and then make it available for use with slight changes on a much smaller and simpler system. TensorFlow is very efficient. It affords great performance because a lot of its implementations have been tweaked and really optimized by Google. And it also has all of the other additional tools like TensorBoard for visualization and TensorFlow serving for deployment. There are obviously challenges that you ought to expect to face if you decide to go with TensorFlow. One of these has to do with the fact that distributed support for distributed TensorFlow is still rather nascent. Another is that libraries are being developed at a frantic pace. So libraries get deprecated or replaced or subsumed every 6 months or a year. But maybe the most significant challenge of working with TensorFlow is the fact that writing custom models, building custom neural networks is not straightforward. If you'd like to use one of the inbuilt or cookie cutter models that are made available for your use, that's very simple, that's very straightforward. But defining a neural network and wiring up all of the neurons by hand is challenging. This is inherently challenging, and there is only so much that TensorFlow can do to simplify or abstract this process for you. This is also a great place to talk about the central abstraction in TensorFlow. Computations in a neural network are modeled using a directed acyclic graph. This is an abstraction which is used in other technologies as well. Flink jumps to mind, as does Dataproc. So we have a network. This is a graph with nodes which represent computations. The edges between those nodes are data items, and those data items are called tensors. That's where the name TensorFlow comes from. We'll have a lot more to say on the computation graph and on tensors in just a little bit. Let's return to the question we posed at the start of this video. The reason that TensorFlow is so popular these days is because it's become the tool of choice for building complicated neural networks. And the reason for that is TensorFlow and neural networks both rely on the same underlying abstraction, which is interconnected nodes which represent operations to be carried out on data items, and edges between those nodes which represent those data items. The TensorFlow computation graph or directed acyclic graph exactly mirrors the setup of a neural network. Remember that neural networks consist of neurons, which are basic operations, and these neurons are wired up in complex ways. TensorFlow easily allows one to create nodes which represent individual neurons and then interconnect those nodes or neurons by passing data between them. Those data items are the tensors, and that's also where the name TensorFlow comes from.